All right, if you need a little extra help with question 8 and 9 from the homework, that is what this video is for. In these questions, you are asked to find a p-value, but they only give you a test statistic in which to do that, and that wasn't explicitly covered in the notes. So I have a question 8 and 9 example to go through, and hopefully we'll connect some dots. So question 8 in your homework looks something like this. They give you the test statistic value, and they tell you what the original claim is. They ask you to identify the test, if it's two-tailed, left-tailed, or right-tailed. That shouldn't be too difficult. And then they ask you to find the p-value, and then determine whether you should reject or fail to reject the null hypothesis. So the tricky part here is we have used the p-value and StatCrunch in class with the proportion stats key, and in order for that to work, you need to know the number of successes and the number of observations, and you don't have any of that information given. You're only given the test statistic. So let's look at how that will work. First of all, in A, the first question, they just asked you to identify if it's two-tailed, left-tailed, or right-tailed. Hopefully that's not a problem. That is given to you by the claim. Since you are claiming that something is greater than 30% or 0.3, that is going to be a right-tailed test. So you would select that from the drop-down menu, and know that when you are doing this problem, you are going to be looking at putting all of alpha in this section, and we know that this is 0.05. Alpha is 0.05 or 5%. It's going to be all in the right tail. That's kind of what your picture should look like. And you were trying to find the corresponding p-value, which p and alpha both are represented by this shaded area that is typically in red in StatCrunch. Your critical values and test statistics are all values on the x-axis, which this time that's what you're given. So you're going to compare, in order to find the p-value then, when you're only given a test statistic. I know in the note questions we went straight to proportion stats and then filled in that, but that is not going to work for us this time. So because we are given a test statistic, or a z-score, I'm going to have to use my normal calculator to pull up a normal distribution chart. Now the mean and the standard deviation, again, we can leave it as 0 and 1. And I just want to refresh your memory. These boxes and what they mean are really important. So if you want the critical value, or given a critical value, or a test statistic, that would show up in this box. That is always the value here on the x-axis. So those values get plugged into that box, the test statistic amount and the critical value amount, depending on what you have. Now, the other box, this one over here, this is always how much area is in this shaded region. And we use alpha for that, so as well as the p-value. These are all kind of represented by the same things. Alpha and the p-value are different. Alpha is what you, like your boundary of where that critical region is going to be, and then the p-value lets you know if it shows up inside that region or outside that region. If p-value is smaller than alpha, then you reject the null, and if the p-value is greater than alpha, you fail to reject. So it's all about knowing where to plug things in. Now, in this particular problem, you are given the test statistic, and you're trying to calculate the p-value. So you're going to plug in the test statistic in this spot, and then calculate what this is. Now it is important, since we've determined that this is a right-tailed test, I know in the claim that p is greater than 0.3, it is really important that you come in here then and adjust that I don't want the left side, I want the right side. So you're going to have to come in and switch your inequality. We were given our test statistic, you're going to plug that in, and then out pops the corresponding p-value. So that is this area. And then you can decide if you would reject or fail to reject the hypothesis based on that. So p-value is 0.062 if I want 3 decimal places. I can't remember what it asked me for. Yeah, 3. 0.062. So we're looking at 6.2% about. The next part of the question then, so p was 0.062, 6.2%, and alpha, they told me in the problem, I'm pretty sure it was 0.05. Yep, 0.05. So I'm trying to decide if I reject it or fail to reject it. 0.05, let's go back to the picture. So here's my picture. 0.05 is definitely less than 0.06. So I would say the p-value is high. Oops, I did that. Yeah, the p-value is high. P-value is the red. The green is my alpha. So since the p-value is higher than alpha, if p is high, the null will fly. So I know I'm going to fail to reject. So it's either A or C. I'm going to fail to reject the null, but I do have to stop and think about what the null was, first of all. And I didn't really, that wasn't an issue here, but in order to answer this question, I need to know what it is. So if the claim is P is greater than 0.3, then the null is P is equal to 0.3. So if the null will fly and the null is not the claim, then we are not supporting the claim. My answer would be A. My choices were we are not supporting the claim, or we do have evidence to support the claim, but we kept the null, so we're not supporting the claim. If we rejected the null, that would be supporting the claim. So A. So it's not too bad. Again, it's just a matter of knowing what to plug in where. P-value, critical value, what goes in what spot. Now question 9 is similar. Again, I'm given a test statistic, so that's that z-score that's going to go in the parentheses. And I have the original claim. This time the original claim is that p doesn't equal something, which means if I just stop and think for a moment about my null, it's going to be p equals, which means my alternative is p doesn't equal. So the alternative actually is the claim. So I might want that later. When I decide if I'm rejecting or not rejecting the hypothesis, I will need to pay attention to that. So first of all, I've got to decide what kind of test it is. This is not equal to, so I'm going to have a two-tailed test. It's not right, it's not left, it's two-tailed, which makes it a little bit more difficult as you are calculating the p-value. So now I want to know what the p-value is. So again, I open up my normal calculator, stat, calculator, normal. I leave my mean and standard deviation alone. I don't need to alter that. But I knew my test statistic was 2.99, so I plugged 2.99 in here. Now this is a two-tailed test. So that means I'm going to have both sides are going to have some coloring. And I know you don't see any coloring unless you look super close. But both sides are going to have some coloring, so keep that in mind. That means there's going to be two test statistics, technically. One's going to be positive 2.99, and then there would be a negative would be there also. So it doesn't matter which one you find. I went ahead and found my right tail, and because I made it greater than 2.99, and I get this tiny little p-value right here. And actually that's not technically my p-value because that's only one side, right? Can you see that teeny bit of red? It's teeny tiny because it's so small. I'm going to actually make it so you can see it a little bit better. So 2.99, there's my part of my p, but remember this is a two-tailed test, so this isn't the only area. There is some down here too. So this area is 0.00139 plus a little, and this would be 0.00139. My p-value is both of those together. So when you're using this to calculate your p-value, just remember if you have a two-tailed test, you're going to have to take this, knowing that that's only half of the shaded in red area, and multiply it by 2, and that would give you your p-value, and you'd plug it in here. So your p-value is still really tiny, if 0.00139, 0.00139, 0.00139 times 2, I'm looking at 0.003 for my p-value. So p is 0.003. Now I want to know if I'm going to reject or fail to reject. We know alpha was 0.001. So, oh no, I have too many zeros. Whew. I was going to say, wow, that's a tiny alpha. Alpha is 0.01. So I'm looking at 1% versus way less than 1%. So P is low. The null must go. Right, we're going to reject the null. So when I'm looking over here at my choices, I know it's either A or C. I'm going to reject the null. Now I've got to come back here and say, okay, if I reject this, that means I'm sort of accepting this, and that was my claim. So I would say there is evidence to support the claim. Sufficient evidence. There is not sufficient evidence. There is sufficient evidence. So I would pick C. There is sufficient evidence to support that claim. All right, so that should help you on those two questions. It's all a matter of knowing which block to plug in. Z-scores, critical values go in the parentheses, and they give you alphas and p-values. All right, hopefully that helps. Talk to you soon.